Alright guys, for today we're going to be going over circle vocabulary. As we all know, vocabulary is the most important part about math because we need to know what we're talking about. So for the first one, we have the word circle. And a circle is defined as the set of all points in a plane given distance from a given point. And what that means is that a circle is a set of every point in here from your center point all the way to the edge of your shape. So everything inside of this border would be considered part of the set of points. These points within the shape is what makes up the circle. Next, we have the radius, and the radius is a segment from the point in a circle to the center. Now, when we refer to the radius, what that is and I'm sure many of us have seen it before, is we're referring to that small segment going from the center of your circle to any point on the edge of your circle. So it has to connect from the center point to the edge of your circle, but it won't go all the way across. If it goes all the way across, now what we're going to be looking at is a diameter. And a diameter is a segment that contains or has the center point. And again, much like the radius, it's going to be one long segment that connects to the edge of the circle. The only difference is that instead of stopping at the center point, it goes all the way across to the edge of the circle again. Next is the center, and what the center refers to is just the center point of a circle. And this is actually among the most important parts because the center point in a circle is what dictates a lot of measurements here. It helps us dictate the radius, and it helps us dictate the diameter. It's where the circle originates from. If you ever draw around in Desmos or other graphing software, you can see that when you draw, it's originating from the center point. Because like our definition says, a circle is the set of all points given the distance from the center point to a given. This center point is among our most important in the shape. Next, we have tangent. And the tangent is a line that intersects a circle at exactly one point. Exactly one point. And I recommend you kind of star it or make it seem more important because that emphasis on the one is what makes it a tangent. So draw another circle, leaving a little bit of room for yourself because typically the tangent goes on the outside of your circle, kind of like this. It should look like your tangent or your line is balancing on the circle itself. And make a note here that this, however you draw it, would be your 1 point. So if a tangent intersects at exactly one point, that means the secant is a line that intersects at exactly 2 points. And again, make that important, because again, that's what separates these two. A tangent intersects at 1, and a secant intersects at 2. So since secants intersect circles at exactly 2 points, we won't have the same instance where it's going to be on the outside of our circle. Instead, your lines will typically be intersecting through the circle. So not exactly in, but it's going to go through, just like that. And to emphasize it once more, make a note of 2 points. So we're getting more into the nitty-gritty of circles. We already knew about radius, diameter, and center points. We've learned about those before. But now we're getting into what really makes a circle. We have our tangents, we have our secants. Now we're going to take a look at chords. The defining difference between a chord and a secant is that a chord is a segment. A chord is a segment. And that segment has two endpoints on a circle. So draw your circle once more. And kind of like how you did for the secant up here, do the same thing, but since it's a segment, we will not be drawing these extended arrows. So I will draw it like this. Notice that's kind of off a little bit, not exactly perfect, because a chord can be a diameter, but like when we were talking about polygons, the diameter cannot be the chord. There's specific parts of the diameter that make it true. Chords can be anything in a circle as long as the segment crosses through and intersects at 2 different points like this. So be sure not to confuse this with the diameter. For the next part, these two are a little bit easier. We have the interior of a circle. And for the interior of a circle, it's about as self-explanatory as it can get. All this is referring to the points in a circle. Or even more generically, everything in a circle. So if you have figures, points, or anything of importance inside of a circle, we would say it's the interior of it. So, for example, we wouldn't say a tangent is a part of the interior of a circle, but we can claim that a chord is a part of the interior, just because it's sitting inside of our shape. Next is the exterior, and that's referring to all points outside of a circle. So draw another circle again, and kind of like how I did here, how I shaded the inside of my circle, make a light shading on the outside. Just as a quick little visual reminder that we're referring to everything outside of our shape. Once more, I'll hit on this again. It's the exterior of a circle, which means that now our tangent actually can be said to be on the exterior. So when I refer to things later on in the lesson as saying interior or exterior, I'm referring to its place related to the shape. Again, chords are an interior segment of the circle. A tangent is an exterior line of the circle. So that's everything to do with the figures. I want to get more into the arcs and the shapes because we're going to be working with that quite a bit. You will be quizzed and tested on these as well. So for the central angle, a central angle is an inscribed. And remember, inscribed means drawn inside. An inscribed angle with a vertex on the center, and two sides that are radii. And I'm going to draw a little bit into my picture here. But I want to kind of touch on this a little bit because it's quite a bit to write, and if you have a better way to write it for yourself, feel free to do so. But what a central angle is essentially is it's an angle inside of our shape where your vertex is the center point, and the lengths of both sides of your angles are the measurement of the radius. So let me show you right here. I'm trying to draw you a nice picture. And let's highlight this here. So this is what we call a central angle because it's sitting on our center point. That's how you'll remember it. Central angle, center point. So right here, our radius make up both sides of our central angle. And again, your vertex is sitting directly on your center point, just like that. But notice here, in this central angle, we have a kind of intercept going on. Something's being cut apart, right? This angle right here is cutting our circle off. What we're going to learn now is how to describe what happens when this is cut. Let's take a look at minor arcs. And a minor arc is an arc of a circle whose length is less than a semicircle. So let's touch on that real fast. Again, lots of stuff going on in this definition, but it's not as bad as it looks. What we're referring to is that intercepted arc that we see above. The minor arc is this smaller cut arc right here. And I'll color it yellow just to see. And if you can't see, I apologize. I'll draw an arrow to kind of make up for it. So see right here, when we're talking about a minor arc, we're talking about smaller arcs like these that measure to less than the length of a semicircle. And a quick refresher, a semicircle is exactly half of a circle, just like that. So if you have a small arc that is cut like this and measures to less than half of a circle, then we can call it minor. All right, let's take a look at the back side. So if we can declare that something is special and give it a name, that means we can measure it. Which means that when we talk about it, we can find the measure of a minor arc. And when we talk about the measure of a minor arc, we're referring to the measure of its central angle. So, again, we've created an angle out of it. So when we're referring to it and we say we want to find the measure of this minor arc, we're finding the measure of this angle specifically. Again, if we can give it a name, we can measure it in math, which means that we've talked about the minor part of it. So we need to focus on what we call the major arc. And the arc, or the major arc, is the exterior of the central angle. So what that means is that if, again, we have a minor arc with a central angle in our picture, we're referring to everything outside of that smaller angle. So in this case, we're not referring to the top right angle, we're referring to everything else, this kind of Pac-Man on the outside we got going on. That's what we're more concerned with right now. And how do you find the measure of a major arc? Is we take the difference between 360 degrees, since that is the measure of all circles, and the measure of the minor arc. So again, it's a little bit wordy, but what this is talking about is that if you could take the difference of the central angle to the known measurement and the known constant of circles, which is 360 degrees, that'll give you this exterior measurement right here for your big old Pac-Man face. And what we're referring to, again, the major arc is referring to everything outside of that central angle. That is what we're talking about. And think about it. Major arc. If we're thinking about something that's major, we're thinking about something that's bigger, more important, right? So we're going to be looking at what is the biggest part of the arc that we can attribute back to the major arc. All right. So we've talked a lot about these and the angles involved with minor and major arcs. But what if we had to find the length, the arc length? That is the length of an arc that is a portion of the circumference. So remember, when we're talking about a circle, the circumference is a fancier word for perimeter. So what the measure of an arc is the measurement of the arcs in relation to the known circumference. When you're taking these measurements of the major and minor arc measurements, what you're referring to is the different specifics that add up together to make it. So just to make it clear, the measure of the minor plus the measurement of the major both equal the circumference. You guys get the picture? It's just the circumference. Those two measurements added together will always equal the circumference measurement. Once you find out what this is, we can start treating it as a known factor or a known constant for the circle that you're given. When you get your circumference, you could find out a lot about your circle with this relationship right here. So let's move on to the measure of an inscribed angle. And the measure of an inscribed angle is the degree of the inscribed angle. The important part here is that the measurement of an inscribed angle is that it is half of the measurement of an inscribed arc. So take a look here. Draw another circle. Now, an inscribed angle, and we'll go back and touch on this definition immediately after, is the angle does not touch your center point. Instead, inscribed angles have a vertex on the edge of your circle, kind of like this. And so if I were to find the measurement of this inscribed angle, then I would take the measure of my arc right here and divide it by 2 to get my degree. That's what we're referring to. And again, an inscribed angle is just an angle whose vertex lies on a circle and whose sides are chords. Remember what I mentioned about chords. They're just two segments resting within a circle where each endpoint lies on the edge of your circle, just like this. So that means these two sides are chords. Make a note for that, just so you can remember. Each side is a chord, not like our central angle where each side is a radius. And because of that, that means our vertex has no real special meaning. Again, when we were talking about central angles, our vertex was the center point. But for here, our vertex is just referred to as an endpoint because it has no specific meaning to us when we're talking about circles. Now, for the circle, let's talk about a semicircle. And a semicircle is just half of the circle whose endpoints are endpoints of a diameter. So take a look here. Remember, when we cut a circle in half, what that makes is a base of your diameter. So in here, you could say that this would be your center point directly in the middle, and the left and the right points right here and right here would both be your endpoints for this full diameter length right at the bottom. When you chop a circle in half, you are chopping along its diameter every time. There could be millions of diameters within one circle alone, and I could draw it out just so you guys can see right here. You could chop along any of these dotted lines. But at the end of the day, what you're chopping along is the diameter. So this base measurement, if you are given something like this, is the measurement of the diameter for the original circle. That's why whenever we need to find the area of a semicircle, we're allowed to divide it into 2. Now finally, now that I've overloaded you guys with all this vocabulary, we're going to finish off with intercepted arcs, some of the easiest, and I've already used this word a couple of times while we've been going over the shapes. The intercepted arc is a section of the circumference a circle. And again, all that's referring to is the part of the circle that's been cut. So in this picture right here, referring to an intercepted arc, we could say that this is an intercepted arc, and we could even make the argument that this is an intercepted arc. That's why we create these names for them. Both of these are intercepted arcs. That's why we declare the smaller one minor and the larger one major. That's where those names come from. Alright guys, that's the end of the vocabulary. If you have any questions or need clarification, please reach out.